Hello all, myself Aniruddha Prabhu, Assistant Professor, Cambridge Institute of Technology, Bangalore. Today I am going to discuss about Naïve-Based technique with one example of text classification. So Naïve-Based technique is a supervised learning technique. You should not forget in particular machine learning we have two techniques, that is supervised and unsupervised learning techniques. In that Naïve-Based technique is supervised learning technique. It uses probability based probability theory based analysis. That means the decision what we are going to take, that will be based on probability. So it is one of the machine learning technique, and this Naïve-Based is used often in classifying text documents into one of the multiple predefined category. This is the main application of this particular Naïve-Based technique. Generally we are going to use it for classifying text documents. So in this particular, let's see one possible example of classification. So here, this is one problem statement. Here the main motto of this problem statement is to classify the test data, that is this data, into class H or class negation of H. For example, here some training set has been given, that is document 1 to document 6. It has been classified with respect to H and negation of H, that is class H and class negation of H. The whole document from 1 to 6 has been classified with the class H and class negation of H. Right now, based on this one, by applying Naïve-Based technique, we should classify this particular test data into either H or negation of H. That means I should answer either it should be yes or negated yes. I should classify this particular test document into either H or negated H class. That is H or negated H class. Let's see step by step. First step is to calculate the prior probability. It means, see here from we have training set from document 1 to document 6. We should consider all the document and we should end up with some probability for both H and negation of H. You can see here first one being probability of H and second one being probability of negation of H, or generally in other words it is like yes document, this is like no document. Okay, let's see how we are supposed to do it. You can see documents, document 1, document 2, document 3, document 4. All four documents will be in class S, so it will be one category. So document 5, document 6, it will be in class no, that will be second category. That's what, based on this one we are supposed to calculate probability. Okay, let's see. P of H is equal to 4 by 6. It is very simple. Number of documents is 6. 1, 2, 3, 4, 5, 6. That is overall training set. Document is 6. In that 1, 2, 3, 4 belongs to S class. That is H. Okay. That's why it is 4 by 6. That is equal to in other form 2 by 3. Okay. Second one being like P of negated H. So go back to that particular problem statement. See, here we have document 5, document ID 6. So both will lie under class no. So out of 6, 2 belongs to no class, that is negated of H. So come back to this first step. P of negated of H is equal to 2 by 6, that is equal to 1 by 3. That means 2 by 3 part of this training set lies under class H. 1 by 3 part of this particular training set lies under class negated of H. Generally we are using negated for the reason this is no. H in the sense yes, negated of H in the sense no. So generally what happens, 2 by 3 lies under yes and 1 by 3 lies under no. So this is our first step, that is calculating prior probabilities. Remember we are using probability, the main reason is Naïve-Bayes technique uses probability based analysis. Okay, let's go for second step. That is calculation of conditional probability. That means here I have class H and class negated H. Based on the data what available in that particular statement, problem statement, I should categorize each and every term uh, into frequencies. How many times they are occurring in that particular class. For example, let's take this one, class H. Let's go back to problem statement. Yeah, class H. Yeah, four rows are there in that. Let's take one example, that is love. P of love of H, that is probability of love in that particular class H. Let's see how many wordings are there. That is how many love terms are there. That is 1, 2, 3, 4, 5, 6. In this particular class H, I have 6 term of love which is frequently occurring. So that will become 6 out of 19. Why it is 19? In this particular class H, that is 1, 2, 3, 4, yes. See the number of terms: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 terms are there in this particular class. In that 19, 6 are love. Okay, that's why the probability of love is 6 by 19. Let's see the same thing for the pain. You can see here pain is not there. Here term pain is not there. Here also term pain is not there. But yeah, here one term pain is there. So it will be 1 by 19. Means out of 19 term, 1 is pain. Okay, next see joy. Here two joys are there. Here one 3. Here one 4. Here one 5. That means out of 19, 5 terms are joy. Next see about kick. That is 1 here. In the third document we don't have anything. In the fourth document we don't have anything. That means out of 19 terms, one term is kick. So it will be 1 by 19. This is regarding class H. Next go to second one. In this what happens? We are going to calculate the probability of term with respect to no. Here it was with respect to yes. Here it is with respect to no. So go back to problem statement. No in the sense these two, because these four are yes, that means class H. These two are no, means negation of H. Obviously these two are no. So in that, first calculate total number of terms: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, out of 9 we are supposed to calculate, how many love are there, how many pain, how many joy, how many kick. Go back to the problem statement. See how many love are there. 1, 2, done. So 2 by 9. How many pain are there? 1, 2, 3, 4. Out of 9, it is 4 terms are word pain. That is 4 by 9. So how many joy are there? 1. Except that we don't have any other word. So it is 1 by 9. How many kick are there? 1 here in document ID 6 and 1 here in document ID 5 and 6. Yeah, it should be 2 by 9. Here in the step 2 we ended up with calculating conditional probabilities for both class H and class negation of H. H means yes, negation of H means no. That's it. Okay, let's go towards step 3. Here step 3 is very simple, since in the step 1 we have calculated prior probability. So in step 1 we have calculated prior probability. In step 2 we have calculated conditional probability. In this particular step 3, probabilities of test instance being H and negation of H need to be calculated. Right now we are done everything until here. So we have calculated from here to here. That is both for class H and class negation of H. But now let's come back to our problem statement. That is our actual main motto is to tell what may be the possible class of this particular test data, that is document 7. This is actually our problem statement. Okay, now in this particular statement what happens, we should calculate probability of class H bar D7. D7 is our test data. Go back to this problem statement. Yeah, here D7, this is test data. So probability of D7 being in class H is equal to prior probability of H. That means prior probability of class H into, we should multiply all possible conditional probabilities. It is like multiplication of this one and all possible conditional probabilities. For example, P of H into, see how many love are there in this particular statement. Here 1 and 2. So 2 word of love are there. That means P of H into P of H into P of love bar H into P of love bar H. So 2 love are there in that particular class H into, okay, see the next, it is pain, after that joy, after that kick, that is into pain in the class H, joy with respect to class H, and kick with respect to class H. Now, whatever the value of this particular probability, simple, we have already calculated this. That is P of H bar D is equal to P of H, that is probability, prior probability of H, that is step number 1. Go to step number 1, that is P of H, that is 2 by 3. So it is 2 by 3 into, see probability of love with respect to H, it is here 6 by 19. 6 by 19. Since in that particular test, this one, this particular test data, we have two wordings of love. That means we should enter it 2 times. We should multiply it 2 times. Since we have two terms of love, we should multiply 2 times. So P of love per H into P of love per H. That is the value of P of love in my step 2 is, you can see here, yeah, it's 6 by 9. 6 by 9 into 6 by 9 into P of pain is 1 by 9. That is 1 by 9 into P of joy is 5 by 9. Sorry, 19. Okay. Throughout I told 9. Sorry for that. It's 19. 6 bar 19. 6 bar 19 into 1 bar 19 into joy. It is 5 by 19. It is 5 by 19. Then kick. It is 1 by 19. 1 by 19. So approximately I will end up with some value near to like 0.000 something, 69, 67 or 69. We'll end up with some value. Okay. Next, after this, this is the probability of that. I'm telling the word, it is probability, not accuracy. Probability of that particular test statement being H. Being H means that particular problem statement, that is test data, can be 0.00067, what do you call that, probably it may be under this particular class H. Now we are done with particular H. Now let's go to particular no. What's the probability of that particular test statement being in class negation, that is no. That is, the formula remains same, that is equal to P of negation of H into multiplication of all possible terms, probability of terms available in this particular test data. That is similar to this one, P of negation of H into P of love, but in the class negation of H. That is 2 times because love is 2 times in this particular test data. That is negation of H. Then P of pain, but it is for the negation of H with respect to negation of H class. Then P of joy, that is negation of H class. Then P of kick for negation of H class. Now already we have calculated this particular values. You can go there. That is P of negation of H. Here it is, yeah, P of negation of H. Just go on substituting that one. After substitution, it will be 1 by 3 into P of love Here you can see this class P of love with respect to negation of H, class negation of H, that is no class, that is this one is yes class, this one is no class. Yeah, it is 2 by 9, 2 by 9 into 2 by 9 into pain it is 4 by 9. Then joy, joy it is 1 by 9. Then kick, kick will be 2 by 9, right? So after substitution and calculating, I will end up somewhere with value like 0.0018. Now that is final step. In the final step, what happens? We know that since Naïve-Based probability of the test instance being negation of H is much more higher than higher than it being H. See here, see the value here. The negation of H value, that is this one. So the test data being in negation of H, the value is 0.0018. So probability of test data, that is D7, being in class H, it is 0.000067. Comparatively, this value is much more higher than this one. That means based on this particular Naïve-Bayes technique, we can come to the conclusion that that particular document, that is D7, will be classified as not of H. That means not of H. So final value will be no here. It's quite simple. Based on probability, what happens? I will just summarize. Based on probability, first we calculated the prior probability of both the class H and class negation of H. Then we calculated the conditional probability of class H and class negation of H. In this one, we just calculated frequent occurrence of this particular terms. Term may be love, pain, joy, kick, multiple terms were there. In that, frequency occurrence with respect to class H and class negation of H has been calculated here. In the step 3, we just applied some formula to formula. Remember this formula we applied for this particular D, that is ID7, D7, to just make sure that which probability will be more for this particular D7. Either it may be yes or it should be no. Actually, if yes is more, obviously it will be yes. If no is no more, obviously it will become no. Here, yeah, that formula was like P of H, that is prior probability into multiplication of all probability related to class H, that is frequently occurring in this particular D7. In other formula, everything was same. The point was simple. Class was negation of H. Here it was yes class. Here it was no class. So out of 19, we had some value. We entered that one. We substituted. We end up with some value like 0.00067. Here also we have calculated this one. This is prior probability, and these things already we have calculated in the conditional probability. Just our work is to multiply each and every term which is there in D7. Since we had some value here, we just substituted the value, we end up with the value something like 0.0000018. So comparatively, the probability of D7 being in class negation of H, in the sense not of H, is higher than the probability of D7 being in the class H. Yes class, no class. Simply in other word, if I want to tell, it is yes class, it is no class. Okay, the probability of D7 being in not class is higher than the probability of D7 being in yes class. So obviously the final value will be like yes, that particular D7 will be in the class of not of H. So finally it will be no. Yeah, hope this is clear. Thank you.